And in today's episode, among other things, you'll see this. China is launching those robots that look like us humans. And these ones are very realistic, all right? Some people even want to marry these robots. We'll see that in a bit. Researchers have introduced an electronic skin that senses damage and regenerates itself. Embryos in space, the Chinese experiment that could define the future of humanity beyond Earth. Maybe one day, right? And in Europe, here's the proposal. Companies hire employees, but instead of human beings, they get humanoid robots to work. In the United States, robots are getting what you could call velvet hands. And all of this is to live among us. Let's break all that down and look at a few more new tech stories. Hello, amazed folks. I'm Realidad Impressionante, and you're watching Realidad Impressionante. You know that future where you talk to a receptionist for several minutes and only find out at the end that she was never a real person? That future has already begun, my friends. It's still in its early stages, of course, but it's already started, you see? Chinese companies are launching a new generation of hyper-realistic androids that are capable of smiling, making eye contact, interpreting emotions, and having conversations in an increasingly natural way. And what's most interesting is that it's not just an isolated project, you see? Everything indicates that China is really building the future described in science fiction through a true ecosystem where humanoid robots can work in customer service, commerce, and even as companions for humans. Some people even want to marry these robots. Yeah, my friends, those of you who have been following me for a while definitely know what the uncanny valley is, right? It's that dilemma where the more human something looks, the more the little details give away that it's artificial. That's basically what's called the uncanny valley. For example, on the face, a stiff smile, a fixed stare, or even movements that don't seem random enough, or even an expression that's out of sync. These are small details that are enough to cause discomfort. Now this obstacle is already starting to be overcome. One example is Xianglan R03, which was developed by Digital Waxia in Shenzhen. Its face has more than 40 degrees of freedom, allowing it to reproduce dozens of micro-expressions with the help of small actuators hidden under this very realistic silicone skin. The robot follows people's gaze. It recognizes when someone approaches and starts a conversation spontaneously, that is, on its own. Its artificial intelligence also uses a dual-brain architecture, separating quick responses from those more complex cognitive tasks, such as interpreting context, language, and emotions. At the same time, just to give some examples, another Chinese company, Qingfei Technologies, took a slightly different approach with its robot Ziru. Instead of building the mechanical structure first, its engineers initially created an extremely accurate anatomical replica of a human face, and only then installed the actuators underneath that kind of skin. This made the movement smoother. In addition, its eyes reproduce the small involuntary movements that we make during a conversation, while the artificial intelligence analyzes posture, tone of voice, and facial expressions, so it can adapt its own reaction even before responding. And these robots weren't created for factories, my friends. They are being prepared to welcome customers in hotels, work in stores, hospitals, banks, and also shopping centers, while other models are even starting to be tested as companions for the elderly and people who live alone and choose this type of robot. Xiaolan, for example, can be fully customized and cost between $30,000 and $50,000. Just as China has become the leader in the production of electric cars, drones, and solar panels, everything indicates that the country intends to do exactly the same thing with humanoid robots, with these androids. The difference is that this time the product will be a machine capable of looking into our eyes, talking and conveying quote-unquote emotions, artificial emotions. And you tell me, how many years do you think it will take before it's normal to see robots like these working in hotels, stores, hospitals, basically throughout our public service infrastructure, and also, well, you know what I'm talking about, right? How long? Tell me. Imagine a robot exploring the ocean floor or even a human diver performing an inspection in very deep waters. During this mission, a cut from a rock punctures part of the equipment. Today, that would mean the end of the operation. But researchers at the National University of Singapore have developed a technology that could radically change this scenario. An electronic skin that is capable of detecting damage, immediately issuing an alert, and starting its own regeneration process, even underwater. The skin is made of a special elastomer containing liquid metal and also magnetic particles. When it suffers a cut or a puncture, its electrical resistance changes instantly, working like a kind of artificial nervous system that identifies the location of the damage. At the same time, the chemical bonds present in the material allow these molecules to reconnect, starting the self-healing process. Another interesting detail is that this system practically does not require a dedicated power source to detect movements and deformations. Using a principle called magnetoelectric induction, small variations in the magnetic field generated by the deformation of the material produce electrical signals that can be interpreted by the sensors. In the laboratory, the skin maintained its performance even after 10,000 deformation cycles, thus demonstrating significant durability for real-world applications. And the tests show even more interesting results in underwater environments. While many adhesive materials lose their efficiency when immersed, this electronic skin was able to fully recover its properties after about 10 days in simulated seawater. The researchers also incorporated smart glove technology that can recognize gestures and transmit messages like help or going up, as well as trigger light alerts when much more serious damage is detected. So far, humanity has achieved nearly everything we've dreamed of, or we're on the way to doing so. For example, permanent colonies on the moon or on Mars. However, there's a much more important question than building rockets or space bases. Can human life really develop outside of Earth? In other words, can we reproduce outside of Earth? To begin answering this question, Chinese scientists have started an unprecedented experiment aboard the Tiangong space station, using artificial human embryo models produced from stem cells. The goal is not to create babies in space, at least that's what they're saying, okay? But rather to understand how microgravity interferes with the early stages of human development. Taking humans to other planets is a huge engineering challenge, yes, but ensuring that future generations can be born and live in these environments might be an even greater challenge. And scientists know that the absence of gravity changes muscles, bones, blood circulation, and even the behavior of cells. What we still don't know is how these conditions affect the first days of an organism's development. As far as we know, no one has ever been born in space, right? It was precisely to investigate this question that the Changzhou 10 mission took models of artificial embryos derived from human stem cells to the Chinese space station. These structures closely mimic the early stages of embryonic development. But you can relax, because according to what the guys explained, they are not real human embryos and do not have the ability to develop and form an individual, thus allowing them to be used as scientific models with fewer ethical limitations. For 5 days, a fully automated system will change the culture medium of the samples daily while they remain in microgravity. Some of the models grow on real uterine cells, simulating the natural biological environment. The other part remains inside microfluidic microchips, capable of controlling with extreme precision the circulation of nutrients and fluids. And at the end of the experiment, all the samples are frozen in orbit and will return to Earth to be compared with identical models grown down here in terrestrial laboratories. And the European industry faces a growing problem, not to mention that almost the whole world is facing this issue, right? With the aging of the population, studies point to a significant reduction in the workforce in the coming decades, especially in industrial countries like Germany. At the same time, many companies still consider traditional automation, the kind done by simple robots, to be slow, expensive, and difficult to adapt. Instead of selling robots as equipment, the startup Nucleus decided to market the service that these robots provide. In other words, the employer will hire an employee just like they do today, but instead of being a human, it will be a robot that imitates humans and shows up at the workplace. That's basically it. To speed up this process even more, the German startup initially uses accessible platforms, such as the Downy-Tree G1, which is a Chinese robot. They do this by adapting the hardware for industrial applications. The models receive more robust motors, reinforced components, and protective coverings capable of withstanding dust, humidity, and typical conditions of factory environments. Instead of waiting years for perfect robots, the company prefers to put functional systems into operation right now, very quickly, and the idea is to keep improving them continuously. Another interesting point is that these robots still can't work entirely on their own, you know? When they encounter an unexpected situation, human operators working remotely can take control for a few moments, guiding the machine until it learns how to solve that problem on its own. This model, known as human in the loop, allows robots to be useful from their very first day on the job, while their autonomy gradually increases as they learn from humans themselves. And just so you have an idea of the level humanoid robots have already reached, my friends, in China, the Expedition A3, developed by the Chinese company Ashbot, has even become a star in a famous TV series in the country. The robot is about 1.73 meters tall but weighs only 55 kilograms thanks to a structure made from a magnesium alloy. Its body has 31 motorized joints powered by permanent magnet synchronous motors, which are developed by the company itself. In the knee joints, these actuators reach peaks of approximately 320 newton-meters of torques, allowing it to perform these kicks, jumps, spins, and these very fast movements, which are typical of martial arts, but with much more fluidity than previous generations of humanoid robots were able to achieve. To achieve this level of mobility, the engineers made some interesting choices, okay? Instead of equipping the robot with heavy sensors like LiDAR systems and three-dimensional cameras aimed at industrial applications, they prioritized a simpler and lighter architecture. The hands were coated with silicone and have 12 degrees of freedom, enough to create expressive gestures, while a screen installed in place of the face displays facial expressions that make the interaction much more convincing. The system also uses several microphones capable of identifying nearby voices without relying on specific commands to start a conversation or a fight, as is the case here. Another detail that really stands out in its operation is the following. The Space Expedition A3 was designed to be easily transported, so it can partially fold its own body to fit into a compact box with wheels. In addition, its batteries can be replaced in just a few seconds, and it offers up to 10 hours of operation. And I can't forget to mention that it uses ultra-wideband positioning, allowing groups of up to 100 robots to be synchronized for coordinated performances. Yeah, things are getting serious and moving fast, right? What do you think? And for robots to really become part of our lives, we can't forget about the hands, right? And they have to be advanced enough to be able to pick up a coin from the table, for example, zip up a jacket, hold a crystal glass, or even wash the dishes without breaking a single glass. The American-Norwegian company 1X Technologies has introduced a new generation of robotic hands for its humanoid robot, New, and in this way is bringing machines closer to a skill that has always been exclusively ours as humans: dexterity. Each hand has up to 25 degrees of freedom, allowing for extremely precise movements of the fingers, palm, and wrist. And instead of installing heavy motors inside the hand itself, the engineers place these motors in the forearm. The movement of the fingers happens through cables that work in a way very similar to human tendons. And this solution significantly reduces the mass at the extremities, making the movements faster, smoother, and more efficient. But strength without control can be a big problem. That's why the hand was also designed to be flexible. Its mechanical system lets the fingers yield naturally to resistance, lowering accident risk. So you won't be breaking skulls out there, thankfully, right? According to the company, the structure can withstand impacts. It can be caught in doors or drawers without suffering serious damage. And it has IP68 certification, making it water-resistant and suitable for household tasks, including those involving food. Another distinguishing feature is touch perception. Sensors distributed throughout the hand continuously measure the pressure applied to each object, allowing the robot to automatically adjust the force applied. In other words, instead of just holding something, it can sense when an object is slipping or when it needs to reduce the pressure to avoid causing damage. This information feeds the 1X artificial intelligence system, making each interaction more precise as the robot learns from the experience it gains in daily use. Lumo, introduced by the Chinese company Robotic, is one of the first humanoid robots developed from the ground up to operate in realistic human environments, where we live and go about our lives, my friends. Its locomotion uses a system capable of continuously adjusting the torque of its joints to walk on different surfaces, such as grass, sand, stones, and even uneven floors. At the demonstrations, the robot performed complex moves, including dances, occasional strikes, and somersaults, and this shows the level of stability achieved by this mechanical platform. But perhaps the most interesting aspect of this robot lies in its intelligence. Instead of simply responding when it receives a command, Lumo combines computer vision, voice recognition, and body control, all to interpret the environment around it. According to Robotic, the system can identify facial expressions, adapt its tone of voice during a conversation, and gradually learn the habits of its user, offering increasingly personalized responses as it interacts with the people around it. Another key feature is performing various functions without hardware changes. The same robot can act as a home assistant, educational tutor, partner for physical activities, or guide in museums and even shopping centers, my friends. This flexibility builds on the company's experience with the Atom robot, previously used in advanced remote operation and precision control tests, as shown in several videos on this channel. My dear friends, thank you so much for staying with me until now. Click on one of the 2 suggestions on your screen and I'll see you in the next one. But before that, make sure you're subscribed, all right? And don't forget to leave a like, okay? Thank you, and I'll see you in the next one. Just click there. Bye-bye and see you soon. Thanks.